Hello, for today's video we are looking at titration, and I've broken up the videos into two. The first one is about the method of titration, and the second one is about all the calculations that you may be required to do for titrations. Now, to begin with, we've got two solutions here. One is acid, one is alkali. Imagine we have exactly the same volume and exactly the same concentration of acid and alkali. You can imagine that if you poured the acid or the alkali into the acid, you would get a neutral solution, and because they are both the same concentration and both the same volume, this is likely to give us a neutral solution. So what we have here is a container, double the volume, but it's now neutral. Now let's just take that step that back a bit, and imagine then, instead of having an equal concentration, imagine we had strong acid, a strong concentration of acid, and the same alkali as we had before. We could probably pour all of this alkali in there and it would still stay acidic, simply because the acid is now much stronger. Now, there is a method we can use to find out exactly how much alkali we need to put in there to neutralize it, and that method is called titration. So let's have a look at how that's done. Now, there's some special equipment that we use here. We've got something called a burette, which you may have seen at school, but it's basically a glass tube with readings on the side that you can read off, and a tap at the bottom which you can let out some of the solution that's in there. So that's our burette. Here we have a conical flask, and inside the conical flask I've got some of that alkali with a little bit of indicator, and this is how we actually do the titration. First step is to add a known volume of alkali into our conical flask. So we are actually finding out how much acid is required to neutralize the alkali in this example. We add it using a pipette. There's two types of pipette we often talk about in science, but the one we're talking about here looks a bit like this. It's made of glass, it's got a little mark here, and it's got a very accurate it's a very accurate way of measuring out a known volume. It's more accurate than using a measuring cylinder. So we add our known volume of alkali into a conical flask, making sure that both of these have been washed out with distilled water to clear out anything that might be in there. We then add a few drops of indicator. Now, it's important that we have the right indicator. One example is something called phenolphthalein. Another one is called methyl orange. We can't use universal indicator because that has a gradual change in color, and it won't show the neutral at a very specific point or a specific enough point. But we can use something called phenolphthalein or methyl orange. The next stage is to pour some acid into a burette and record the reading. So here's our burette. We pour our acid in here using a funnel, and let's just magnify what the burette looks like. So if we were to magnify the burette there, you can see you've got a line here that's the top of our acid. The line won't be straight. We have a little structure here called a meniscus, so it goes almost slightly in a curved shape. It's slightly curved towards the ends there, but what we do is we measure along the bottom of that line there. So here we can see it's exactly at that reading there, whatever that might be. I haven't put it in on this diagram. Okay, so that's the next stage, and then after that we open the tap and add a small amount of acid and swirl the conical flask to mix it. So here's our tap. We open the tap, add a small amount of acid and give it a mix. We then keep adding acid till the solution is neutral, and that will be shown by the color change in the indicator. I think for phenolphthalein it goes from pinky to colorless at the point at which it gets at the correct point, but we keep on adding until the solution is neutral. Next stage is to repeat at least 3 times. Now, the reason why we repeat is because often on the first go you don't get it quite right. You go maybe a bit too far, but once you realize roughly how much you're going to have to add, you can refine your measurements. Here's a sample of results that you might get. So we've got the volume of acid added is 26.2, 26.1, 29.3 and 25.9. And what we can do here is we can take the readings and we could actually take the mean reading to give us a better value. But before we do that, you have to notice here that we've got 26.2.1. These are very close to each other. 25.9 is close to the other two. This one here is what we call an anomalous reading. It's quite far away from the others, and there's two things you can do about that. What this person might have done is actually just ignore that reading when they calculate the mean, or they actually carry out the experiment one more time to get another reading to see if they get one that's close to the others. Okay, so that's quite an important point to measure, but often for our titration we carry out at least 3 times. We can actually keep on going until we get exactly the same reading twice, but that ends up being quite long sometimes. But taking 3 readings, seeing if they're close, gives us a good indication that we have the right or accurate measurement. Okay, so this is the method by which you carry out your titration. If you're lucky, you'll get something like this in a 6-mark question, but certainly something you need to know. Next video we're going to look at calculations, so that's me done for this one. Thank you for watching, and I'll see you again soon.